Welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology. In this course, we will see about the embedded system and IoT subject for biomedical engineers. The topic is here cyber security. So let us see the what is cyber security. So cyber security in the context of IoT refer to the protective measures and protocols implemented to safeguard IoT system from cyber threat and attack. So we needed to safeguard our IoT devices. So as IoT devices become increasingly prevalent in various sectors, including healthcare, cybersecurity has emerged as a critical concern due to the sensitive nature of the data being processed and transmitted. So vulnerability in IoT system. So first we want to define that is what is vulnerability. So vulnerability refer to weakness or flames in IoT system that can be exploited by attackers to gain unauthorized access, disrupt operation or steal sensitive data. For example, unpatched software vulnerability in a medical IoT devices could allow attackers to gain control of the devices or access patient data. So types of a vulnerabilities. First type is a hardware vulnerabilities. So hardware vulnerabilities, these include flaws in the physical components of IoT devices such as a weak encryption of data and storage media, insecure physical parts. For example, lack of hardware-based encryption in wearable medical devices, making them susceptible to data breaches. Next is software vulnerabilities. Second type is software vulnerabilities. These include bugs, flaws or inadequacies in the software that operates IoT devices such as outdated firmware, poor coding practice or inadequate testing. Let us consider the example of a software vulnerability, that is a buffer overflow vulnerability in the software of a connected insulin pump, potentially allowing unauthorized access to the device. Next type is a network vulnerabilities. These include weakness in the communication protocol and network infrastructure used by IoT devices such as unsecured Wi-Fi connections or lack of network segmentation. For example, unencrypted data transmission over public Wi-Fi networks, exposing sensitive patient data to airdropping. Next one is penetration testing in IoT system. So penetration testing means it is a penetration testing or pen testing is a simulated cyber attack on a system to identify and exploit its vulnerabilities with the goal of assessing the system security posture. So what is the purpose of a penetration testing? Why we needed a penetration testing in IoT means to evaluate the effectiveness of security measures and identify areas where improvements are needed. For example, conducting a pen test on a IoT enabled hospital system to identify potential entry points for hackers. Next, what are the steps involved in penetration testing? So penetration testing means it is a simulated cyber attack on a system to identify and exploit its vulnerabilities. So first step is a reconnaissance. So gathering information about the target IoT system including network architecture, a device in use and existing security measures. For example, mapping out the network of connected medical devices in a hospital to identify potential vulnerability. And next one is a scanning. So using tool to scan target system for vulnerabilities such as a open port, weak password or outdated software. Example, scanning an IoT-enabled patient monitoring system for open ports that could be exploited by attackers. Next one is exploitations. So attempting to exploit identified vulnerabilities to gain unauthorized access or control over the IoT system. For example, exploiting a software vulnerability in a connected pacemaker to gain control of the devices. Next, reporting, documenting the finding of the pen test, including identified vulnerabilities, successful exploits, and a recommendation for remediation. For example, providing a detailed report to hospital IT staff on the vulnerabilities found in their IoT infrastructure with suggestions for improving security. Next, encryption technologies in IoT. So, what is the encryption? So, encryption is nothing but encryption is the process of converting data into a coded format that can only be read or decrypted by those who possess the correct key. It is a fundamental component of the IoT security, ensuring that data transmitted and stored by IoT devices is protected from unauthorized access. For example, encrypting patient health record transmitted between the IoT devices and a hospital central server. And next, let us see the types of encryption used in IoT. In the encryption, we have here three types of encryption types are there. One is a symmetric encryption. So symmetric encryption means the same key, the uses the same key for both encryption and decryption. So it is a fast and suitable for real-time data transmission, but requires secure key management. For example, using AES. AES means it is an advanced encryption standard to secure data transmitted between a wearable health devices and mobile app. So next one is a asymmetric encryption. Uses a pair of key, that a public key for encryption and the private key for decryption. It is a more secure but slower than the symmetric encryption, making it suitable for initial secure key exchange. Example, utilizing RSA encryption for secure key exchange between the medical IoT devices and cloud-based healthcare platform. Next encryption is a hybrid encryption. So it is a combines a symmetric and asymmetric encryption to leverage the strengths of both methods, typically using asymmetric encryption to exchange a symmetric key. For example, a hybrid approach in securing the communication between an IoT devices and healthcare provider server, where RSA is used for key exchange and AES for data encryption. So encryption protocols for IoT, we have a lot of protocols we are using in for encryption. In mainly, that is a TLS, that is a transport layer security and security sockets layer protocol, and then internet protocol security, and then message queuing telemetry transparent with encryption. This type of protocols we for using in the IoT. I hope that all of you understand about the cyber security. So cyber security, we need to protect our IoT devices from the threats. Thank you.